All right, we are talking about ratios and proportions, and just a little review of what a proportion is. It's two ratios that are equal. Okay, so I could have something like 2 over 4 equals x over 10. That is a proportion. Those two ratios are equal. Now to actually solve this and figure out what that x is, what number that is, we would solve by doing cross multiply and divide. Okay, that's how we will solve a proportion. So cross multiply and divide, I'll rewrite the proportion. We are going to multiply the numbers that are across from each other. Okay, that's why it's called cross multiply and divide. So we'll do 2 times 10, which is 20. And then we will divide by 4. So 20 divided by 4 is 5. So the number that goes in the x is 5. So if we put a 5 up here, 2 over 4 reduces to 1/2, 5 over 10 reduces to 1/2. So that would be two ratios that are equal. They reduce to the same thing. Okay? A few vocab words that we should be aware of and familiar with. We have unit rate, constant of proportionality, and constant of variation. Those are all referring to a ratio that has the number 1 in it. Okay, a ratio containing the number 1. So whenever a problem says find the unit rate or the constant of proportionality or the constant of variation, you're trying to find a ratio and reduce it so that there is 1, the number 1 in the ratio. Okay? For example, if I was trying to figure out what I get paid per hour, that would be how much money in 1 hour. Okay, if I was trying to figure out how many hours I work per day, so it'd be how many hours in 1 day. Okay, all of those are unit rates, constants of proportionality, or a constant of variation because they have the number 1 in them. All right, we're trying to figure out if we have a proportional relationship in a table and in a graph and what that would look like. So on a table, if it's a proportional relationship, all the ratios will reduce to the same unit rate. Okay, for example, if my table had 2 and 4, 3 and 6, 5 and 10, 5 and 10, all of those ratios actually reduce to the same unit rate. They all reduce to 1/2. So this would be an example of a proportional relationship. 2 over 4 reduces to 1/2, 3 over 6 and 5 over 10 all reduce to the same unit rate. Okay, on a graph, if it's a proportional relationship, it's going to be points on the same line that go through the origin, 0, 0. Okay? So if I draw a graph here, the origin is right here at 0, 0. If it's a proportional relationship, the line must always start there. It can go up steep or it can go flatter, but the line must always start at 0, 0, at the origin. Okay? Now any points that are on that line, those blue dots are supposed to be on that line. So any dots on this line are in the same proportional relationship. Any points on this line are in another proportional relationship together. And any points on the third line would be in a proportional relationship together as well. So for it to be a proportional relationship on a graph, it has to go through the origin, it has to make a straight line, and then any points on that line are also included in that proportional relationship. So any points on that line could be ratios in the table that would be included in that proportional relationship. Okay, and then when we're talking about equations, This is the equation for a proportional relationship, y equals mx, where m is the unit rate. So if I had y equals 10x, this 10 would be the unit rate. It would be 10 to 1. And if we graph that, it's going to give us a graph of a line that starts at 0, 0 and makes a straight line. Okay? So a graph like this, in this form, makes a straight line through 0, 0.